Before we dive into XT Series Electrode Steam Humidifier Mini drains, let's look at how XT Series humidifiers operate. At startup, the electrodes are energized, but there's no water between them, so there's no electrical current. This is the 0 point on the nominal current curve shown in the graph. Then we add water, and electrical current begins to flow through the water between the electrodes. The water level continues to rise until we reach the target current or until the water level reaches the high water sensor. In this example, the water level reached the high water sensor before the target current was reached. As the electrical current increases, the water heats up and begins to boil, continuing until enough water boils away to make the current drop to a level that triggers the fill valve to open. As more water enters the cylinder and boils away, conductive ions get left behind, so the conductivity of the water in the cylinder gradually increases. As boiling continues, the water can pass more current with the same amount of electrode immersion. After several fill intervals and boiling away of water, the current increases to the nominal current. In this example, with this model, nominal current is 14 amps. The amount of time it takes to reach the nominal current depends on water conductivity, with low conductivity water taking longer. Upon reaching nominal current, the humidifier is finished ramping up, and the current cycles up and down between 10% above and 10% below nominal. As boiling continues, minerals continue to concentrate, and conductivity continues to increase, resulting in less and less electrode immersion required to maintain nominal current and steam output. Eventually, the water becomes so conductive and the electrode immersion so low that if boiling was to continue, the water would temporarily drop below an electrode, leading to degradation of the electrode. At this point, or just before, the vapor logic controller will reduce the water conductivity by draining the cylinder and refilling it with fresh water of lower conductivity. This drain and fill cycle temporarily interrupts steam output. For applications that cannot tolerate interruptions in steam output and the potential drop in space RH, DriSteem recently introduced the mini drain function. Mini drain allows continuous steam production with small drains and fills throughout the cycle. XT Series humidifiers are shipped with mini drain disabled. So, when should you enable mini drain? If you have low conductivity water or need more consistent steam output, mini drain should be enabled. So why should mini drain be enabled with low conductivity water? All of DriSteam's isothermal humidifiers can use hard, softened, deionized, or reverse osmosis water, except for XT Series electrode humidifiers. Electrode humidifiers require conductive water and therefore cannot use water with little or no total dissolved solids, such as deionized or reverse osmosis water. Electrical conductivity in water is proportional to the concentration of conductive ions in the water. The higher the concentration of conductive ions, the higher the conductivity of the water. When the water becomes too conductive, the unit will attempt to reduce conductivity by draining and start the process all over. With mini drain disabled, the unit will shut off to perform the full system drain, and there will be no electrical current and no steam production at that time. After the full drain, the unit has to go through possibly a long, maybe even 8 to 12 hours, ramp-up function. With mini drain enabled, the unit runs while performing slow, tiny drains and fills, allowing continuous steam production and steady RH consistency with minimal swings in output and operational interruptions. In general, lower conductivity water leads to operation with the electrodes almost fully submerged. With higher conductivity water, the electrodes operate at relatively shallow submersion depths that can lead to high current densities, arcing, and degradation of the electrodes. Enabling mini drain can be very helpful at lower conductivities, but the benefit may be reduced at higher conductivities. Mini drain can be enabled as follows using the Vapor Logic controller keypad display: Main, Setup, XT Management, Mini Drain, Enable. This chart shows ramp up with mini drain disabled and running for about 26 hours with water conductivity of 140 microsiemens. You can see here the dips in output when the unit drains and refills. Note that with a very clean cylinder and very low conductivity or clean water as starting conditions, it takes several hours for the water conductivity to concentrate through mineral precipitation in order to reach full output. After operating at full output for a period of time, if mini drain is disabled, the unit goes through a full drain cycle, refills with low conductivity water, and has to start concentrating conductivity all over again, resulting in delays to reach full output again. Even with clean water, eventually enough minerals will remain in the cylinder after a drain to minimize or eliminate the need to concentrate conductivity for full steam output. Here is the same humidifier with the same water, but mini drain is enabled. This time, several mini drains occur in the same 26-hour period as shown previously, but the output is much more consistent with mini drain enabled. Note, with mini drain enabled, the very first cycle still takes a long time to concentrate, but because only a small amount of water is drained, the unit recovers at full output almost immediately. As you know by now, the key to successful application of electrode humidifiers is water conductivity. On this map, you can see that water chemistry varies greatly by location. The conductivity needs to be in the range of 125 to 1,250 microsiemens per cubic centimeter of water. That number is not always available from the local water guy. You can measure water conductivity with a kit, and some municipalities will provide it. One thing you need when selling electrode units is a good sense of the water at the site where electrode humidifiers are specified or sold. 125 to 1,250 microsiemens is approximately equivalent to 3 to 36 grains per gallon of water hardness. This is a good approximation, but not a strict conversion. When you're working with electrode units, you need to find out everything you can about the water. In addition to the mini drain function, you can improve your low conductivity water XT operation by using DriSteem low conductivity cylinders that work with 125 to 350 microsiemens for most XT series models. You can find the full list of cylinders available on our parts website. Keep in mind, even if you measure the water conductivity and get the correct cylinder, the startup time may vary based on the job location. In some cases, it could take hours to reach full capacity. For critical applications where full capacity is required quickly, our resistive electric steam humidifiers would be your best option. Please contact your DriSteem representative for help choosing the best solution.